In the grand theatre of the cosmos, stars are the protagonists living out dramatic lives only to end in an equally dramatic death. Each star, no matter how bright or faint, how large or small, follows its own unique path, a stellar journey that's both fascinating and awe-inspiring. Like characters in a grand cosmic play, stars are born, they live, and eventually they die. But unlike the fleeting existence of human life, the life cycle of a star spans billions of years, making it a spectacle of cosmic proportions. Each stage in a star's life contributes to the rich tapestry of the universe, from the nuclear reactions that fuel their radiant glow to the explosive finale that marks their end. The death of a star is not just an ending, but a transformation, a new beginning in the infinite cycle of cosmic life and death. Every star's demise is a spectacle worth understanding, a story that unfolds over billions of years. Our story begins with a star's birth, an event sparked by the collapse of a dense cloud of gas and dust. Imagine a cosmic dance where particles come together, pulled by the force of gravity. Over time, these particles form a protostar, the first stage of a star's life. As the protostar grows, it heats up, and a process known as nuclear fusion begins. This is where hydrogen atoms collide and fuse to create helium, releasing energy in the form of light and heat. This is the heartbeat of a star, its life-giving process. The size of the star is crucial. Larger stars burn brighter but live shorter lives, while smaller stars, like our Sun, burn more steadily over billions of years. As the star ages, it exhausts its fuel. The fusion slows, the light dims, and the star cools. This is where our true story begins, with the star's inevitable demise. As the star exhausts its fuel, it faces an inevitable fate: death. But this death is unlike any other. Stars, these celestial bodies of radiant light and heat, seemingly eternal and unchanging, are in fact anything but. They are born, they live, and they die. And it is in their death that we truly see the grandeur of the universe unfold. A star's demise is dictated by its size. Smaller stars, those up to about 8 times the mass of our Sun, meet their end in a relatively peaceful manner, becoming what we call a white dwarf. As these stars burn through their nuclear fuel, they shed their outer layers, leaving behind their hot, dense core. This core cools and dims over billions of years, leaving a faint white dwarf behind. In contrast, the death of a larger star is a much more violent affair. Stars greater than 8 solar masses undergo a spectacular explosion known as a supernova. As they exhaust their nuclear fuel, their core collapses under its own gravity, triggering a shockwave that blasts the outer layers of the star into space. And what remains of these larger stars? Well, there are 2 possibilities. The first is a neutron star, an incredibly dense object with a mass greater than our Sun, but a size comparable to a city. The gravity is so intense that a teaspoonful of neutron star material would weigh about 1 billion tons on Earth. The second, even more intriguing possibility is a black hole. If the core of the star is massive enough, it will collapse to a point of infinite density, creating a hole in the fabric of space-time from which nothing, not even light, can escape. The death of a star is a dramatic, violent event, but it's also the birth of something new and potentially even more fascinating. The cosmos, in its infinite wisdom, uses the death of stars to create new elements, seed galaxies with the building blocks of life, and sculpt the universe's breathtakingly beautiful celestial landscapes. In the wake of a star's death, the universe is forever changed. The demise of these celestial bodies is not a mere extinguishing of light. Rather, it is a spectacular explosion of matter and energy known as a supernova. This process is a key player in the cosmic theatre, contributing to the constant evolution and transformation of the universe. The remnants of a dead star do not simply vanish into oblivion. Instead, they form nebulae, vast clouds of dust and gas that serve as stellar nurseries, birthing new stars and planets. The heavier elements forged in the heart of a dying star are scattered across the cosmos, becoming the building blocks for future celestial bodies. Even in death, stars continue to shape the universe, highlighting the intricate interconnectedness of all cosmic phenomena. So, in the grand scheme of things, the death of a star is not an end, but a beginning, a cycle of cosmic rebirth that continues the great drama of the universe.